Here is a percent yield practice problem, and it is very similar to a practice problem you did with limiting reactants earlier. So I went ahead and I did the first steps of this problem that I'll explain in a minute, but these should already be on your paper somewhere from an earlier practice problem. So here's our reaction, already balanced. Always have to make sure it balances. And then here's our problem. Mr. Wilson predicts that 61.4 grams of ammonium, right here, will be produced when you combine 28 grams of nitrogen gas and 10 grams of hydrogen gas. Don't need a question mark right there, need a period. There we go, correcting my own typos before you can. Based on his prediction, what is the percent yield of this reaction? So when you are doing percent yield with a reaction like this, it's actually a pretty long process. I just shortened it up by already doing this for you, but the first thing you have to do is you have to figure out how much product will actually be produced. In order to do that, you have to go through the limiting reactant process, meaning you'd have to take 28 grams of nitrogen right here, 28 grams of nitrogen, and you have to take 10 grams of hydrogen, and you have to convert those both into grams of product, because you have to know how much is actually going to be produced. So you have to figure out what the limiting reactant is and how much will actually be produced. So I did that for you here. This should be in your notes or on your paper already. I took 28 grams of nitrogen, converted that to 34 grams of ammonium, and then I took 10 grams of hydrogen, converted that to 56.7 grams of ammonium. Then you determine which is your limiting reactant. So here, our limiting reactant is going to be the nitrogen, and it turns out we are going to produce 34 grams of ammonium. So that is the number we're going to be working with. This is how much, this right here, whichever your limiting reactant produced. So whichever number is lower, this number right here, the lower number, not only is that the amount that's actually produced and the amount produced by our limiting reactant, that is also our actual yield. So as far as percent yield goes, you have that equation. The amount actually produced by the limiting reactant is our actual yield. How do we know our theoretical yield to finish that equation? Well, you go back to the prediction in the problem. I predicted that 61.4 grams of ammonium would be produced in an ideal condition for this reaction with these different reactants. In reality, I was way off. Only 34 grams of ammonium were actually produced. So remember, our formula would be actual yield divided by the theoretical yield, and then we multiply that times 100. Our actual yield here, how much was actually produced, is whatever was produced by the limiting reactant. So our actual yield is 34 grams of NH3. We divide that by the theoretical yield, what Mr. Wilson predicted, 61.4 grams NH3. That right there, 34 divided by 61.4, gives us 0.5537. So then I multiply all of that answer by 100 times 100, and I end up rounded with 55% yield. So based on my predictions, Mr. Wilson's predictions, this was my theoretical yield, this is how much our limiting reactant actually allowed us to produce. Our percent composition for this problem right here would be 55%. So that would be our percent yield. Now, like I said, that's typically going to be a longer process because you have to work all this out on your own. You should still go ahead and show your work so you remember, and then you go ahead and do the actual yield divided by theoretical yield times 100, and you get a 55% yield of ammonium. Another successful video.